Hello class, today we're going to talk about the angle-angle similarity theorem. What this does is this says that if you have two angles in one triangle congruent to two angles in a second triangle, then the two triangles will be similar. Right? Not congruent, similar. Right? And if you remember, we said that for two triangles to be similar, then all of the angles have to be congruent, right? But this is saying, hey, you only have to hit two angles congruent. And the reason that works is because we also have that third angle theorem, which says if two angles are congruent, the third angle has to also be congruent, because they all add up to 180. So whatever these two are, it only leaves the same number for that third angle. So if we have two angles congruent here, we've got two angles there, then the two triangles must be congruent. Now this only works for triangles. This does not work for quadrilaterals or pentagons or hexagons or anything else. Only for triangles. And so we can say the triangle ABC is similar to triangle DEF because we've got two sets of congruent angles. So let's take a look at this. What we want to do is determine, are these two triangles similar or not? If they are, we need to write a similarity statement. And we need to explain our reasoning either way. Okay? The similarity statement, again, that's just this right here. We say one triangle is similar to another triangle. So here we go. Triangle ABC, we have a 15-degree angle and we've got a right angle. Triangle EDF, again, we have a right angle, and this one is a 75-degree angle. Now, what we need to do is, before what we would have to do is prove that all three sets of angles are congruent. Now we only need two, because if two of them work, the other one's going to work too. Alright, so we know that angle A is congruent to angle E, because they're right angles. So what we need to do is figure out, is angle B congruent to angle F, or is angle C congruent to angle D? Right? If we can do either one of those, we don't have to do both, just one of them, and that'll get it done. So let's take a look at triangle ABC. Triangle ABC, we know that the measure of angle C plus the measure of angle B has to be 90 degrees, right? Because the acute angles of a right triangle are complementary. So that means that the measure of angle C is 75 degrees, and that does match up with the measure of angle D. So angle C and angle D are congruent. Angle A and angle E are congruent. Triangle ABC must be similar to triangle EFD by angle-angle similarity. Alright? So, simple enough, not too big a deal. I want you all to go ahead and pause the video and work out number 2. Are these two triangles similar? Okay, you're back. Let's see how you did. Okay, we've got one congruent angle right here, angle C and angle F. We just need to figure out, do one of these two match up? So we're not going to say they're complementary this time because we don't have the right triangles, but the angles do need to add up to 180. So measure of angle A plus 116 plus 30 is 180. So the measure of angle A is 34 degrees, which does not match up with the measure of angle D. So those angles are not congruent, so these triangles are not similar. Alright. So let's take a look at number 3 and 4 here. We need to show that these two triangles are similar. Remember, when it says show, that basically means to prove it, but you don't have to do a formal 2-column proof or anything like that. Right. Basically means these things should be similar. How do you come up with it? Well, let's see. We've got triangle ACE, we've got triangle BCD. They do tell us that these two sides are parallel. And if we got parallel lines, then we can do stuff with our angles here, right? And so these angles are corresponding. So the measure of angle A is congruent to angle DBC because these are corresponding angles. And corresponding angles formed by parallel lines there. We also know that angle ACE and angle BCD are congruent because they're both angle C, so that's reflexive property. It's congruent to itself. And so again, we have two angles congruent. So by the angle-angle similarity theorem, triangle ACE is similar to triangle BCD. Okay, now pause the video and I want you all to work number 4. Okay, let's see. We've got two sets of parallel lines. So again, we can do stuff with that. Cut by transversal. So this time we can have, we've got angle PQS and angle QSR. Those are alternate interior angles, so those are congruent. And angle SQR and angle PSQ, those are alternate interior angles, so those are congruent. So I've got two sets of congruent angles by the alternate interior angle theorem, and so by angle-angle similarity, our two triangles are similar. Alright, well, this is all well and good, but here we have a situation. Flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5 foot 4 inches tall, casts a shadow that is 40 inches long. We want to know how tall the flagpole is. Okay, I thought we were talking about triangles. There's no triangles on this, right? Well, actually there is. If you take the flagpole, and you take the flagpole shadow, and then you take that beam of sunlight that formed the shadow, all of a sudden you've got a triangle. And you've got another triangle here for the woman and her shadow. And since the sun's in the same spot, these are formed by the same sunbeams, right? The same angle there. That means that these sunbeams are all parallel. And so once again, we've got corresponding angles, just like we had a minute ago. So angle-angle similarity says these two triangles are going to be similar. And if you have similar figures, all it is proportions to find the missing length. So let's set up our proportion. We've got a 50-foot shadow over a 40-inch shadow equal to a flagpole, which we don't know how tall that is, and 64. Where did this 64 come from? Well, that came with this 5 foot 4 inches. Since our shadow is in inches, we made our woman, we converted that from feet to inches. Since this one's in inches, change that one in inches. A little bit easier. Okay, so all we got to do now is cross multiply and divide. 50 times 64 divided by 40, and x equals 80. So our flagpole is 80 feet tall. And that way, this is something that's very useful. We can use similar triangles to measure things that we normally couldn't measure. Things that are too tall, because we don't have a tape measure that's 80 feet tall, 80 feet long. And even if we did, it'd be kind of hard to get it up there, right? But also things that how wide things are that you can't really get across ways, like how wide is a river, how wide is a canyon, how wide is this busy highway that you don't really want to walk across with a tape measure, right? Because you get flattened, you know, things like that. And so similar triangles are pretty good for that. This is one method that you can use to view those. So hopefully this was helpful, and I will see you next time.